All right, so in lesson 2.3, it's from your book 3.2 and 3.3. We're going to talk about statements, conditionals, and biconditionals. And I didn't quite say that right, but okay. So a statement is going to be, like everyone in my class is, 6 foot tall. And it may be true or false. Okay. And normally a statement is a lot of words. And so you can call it by a lowercase letter, like P. That might be the statement I just said, like, everybody is 6 foot tall in my class. And so you could call it Q, you could call it R, etc. But it just kind of represents that statement. And then negation has kind of like that swoopy thing in front of it. That means not, okay? The opposite of what you have said. So if you have a statement, then the swirly thing in front of it would be the opposite of that statement. And so, and it would have the opposite truth of it. Truth value represents if something's true or false. And we talked yesterday about, this is true, everybody at Olathe South is very kind. You're like, well, not necessarily. You just need one counterexample to be like, yeah, not so much. But you could talk about the truth value of a simple statement, okay, or a compound statement where it's multiple statements together. And so, and speaking of compound statements, here's one right here. Compound statements, there's a couple different kinds we're going to talk about. Two or more statements put together. Well, they could have, just like in English, they could have the word and between them, or they could have the word or between them. A conjunction, it has the word and between them. And that means that both or all of the things have to be true. And for it to be true. So like to have a square, you need 4 congruent sides and you have to have 4 right angles. Okay, so if either one of those isn't true, then you don't have a square. And so the word and is important. That means that both things have to be true for it to work. For it to be a disjunction, that means or. And that means that at least one of the things has to be true for it to work. More could be true. So like if you have a cat or a dog, or both. Okay, and so you could have a cat or you could have a dog or you could have both. To attend Olathe South, you could be a student or you could be an employee, or maybe I guess you could be both. I'm not sure that's possible, but or means at least one should be true. And there's the shortcuts that are written for both of those. A conditional statement is going to be kind of like what your parents do. They say, if you do this, then this will happen. Okay, and so, if you eat your veggies, well, then you can have dessert. Or if you get good grades, you can have $100 at the end of the year. Or, if you have some NHIs, you're going to lose your phone. Or, those types of things. And it also could be, if you put money in a vending machine, well, then you're going to get candy out or you're going to get a snack out. So a compound statement that has an if-then part of it. Okay. Now, how do you disprove it? Well, you do the if, but then the then does not happen. So if you put money in a vending machine and then you don't get something out, well, then that's a problem. Okay. That's how you disprove. You're like, that's how it's supposed to work, but it didn't. Okay. So a counterexample would be, so I did the hypothesis, but the conclusion didn't happen. Okay. And so examples can't prove that it's going to be true, but just one counterexample can prove it false. Now, how can we use these in math? Well, we're going to use conditional statements a lot in this chapter. How? Well, we're going to be using deductive reasoning about like shapes. We're like, if you have a triangle, well, then you have 3 sides. Well, then if you have 3 sides, well, then we can move these if-then statements to prove certain problems. Say, therefore this is true. So using if-then statements to prove, using deductive reasoning, certain problems results. Okay, so we can write conditional statements as if-then. Okay. And then a lot of times we see them as P then Q. And this means if you have P, then Q follows. Okay, so that's really a good thing to hold on to. What does this arrow mean? If you have P, then Q follows. The P, or the thing on the left, is called the hypothesis. And the hypothesis is the cause. Okay, if you put money in a vending machine. Okay, now the word if actually is not part of what you put. Okay. So you would write, put money in a vending machine. Okay, not if you put money in a vending machine. So if you're writing an if-then statement, you would use the word if. But if you're just saying, what is the hypothesis? You would say, put money in a vending machine. Okay, the conclusion is what follows the result. Okay, so the conclusion is the result, and it follows the word then. Okay. Now, then is not actually part of the conclusion. So, if you put money in a vending machine, then you will get a snack out. Okay. That's an if then statement. But what would be the hypothesis? Put money in a vending machine. What would be the conclusion? Um, you will get a treat. Okay. So that is the conclusion. Not then you will get a treat, but just you will get a treat. So that is going to be a conditional statement where there's a hypothesis and a conclusion that follows from it. Okay. A converse. Well, we talked in class, and I remember as a kid kind of being weirded out. My sweet dad, who's now 73, was like, hey, I remember when I was, older, he remembers when Converse shoes came out, and they were really kind of an innovative thing. And if you've seen them, they have the star on the side, a little circle on the inside of your foot, and they're kind of like a high top tenny. And this was an innovative thing, and I'm pretty sure they said Converse because it was kind of a big deal. I remember it was a great big deal for basketball because you could wear them in a gym and your feet wouldn't slide around. And so it's kind of one of the first pairs of shoes that had a rubber bottom on them, as far as I best know. And it was great for basketball because you could play. And so the converse of a statement turns things around, just like when those shoes came out. It switches the hypothesis and the conclusion. So it's not P then Q, but it's Q then P. So like if P then Q was, if you eat your veggies, then you would get your dessert. Well, then flipping those would be innovative. Listen to this. If you eat your dessert, then you get your veggies. You're like, what? And sometimes the converse is so not true, and sometimes it is true. And so it just depends on the situation that you're talking about. But converse is going to be you flip the hypothesis and conclusion of that original conditional statement. So you flip them. So it's kind of like, what? A shocking thing. And so that would be a converse. Go flip the order. So you can say, flip this order. Okay. Now, you've heard the word by, okay? Bicycle means two. Biconditional means there are two conditions, okay? What are the two conditions? Well, the conditions are if the conditional works like the normal, if P then Q, and also so does the converse, Q then P, okay? Well, then you have a biconditional statement where both ways work, okay? What do you mean? Well, think about shapes, okay? If you have a triangle, then you have three sides. Okay, try it the other way. If you have three sides, well, then you have a triangle, right? Okay, well, that would absolutely be a biconditional statement because both P then Q and Q then P, the converse and the conditional, both are true. So therefore, it's a biconditional situation where both ways work. So what do they do with that? Okay, you put the arrow going both directions because both ways are true. And also they like to use if and only if. Okay, so you have a triangle, and think about it, you have a triangle if and only if you have three sides. That's true. Okay, what if you had four? No, it has to only have three sides. So there are some things in math where it's really only true if this is your situation. I didn't mean to cross that out, but if and only if. So if they mean if and only if, they put IFF. They spell it dumbly. Okay, so an if with two F's. Okay. And we'll talk about that in a minute. So if both ways are true, the conditional and the converse, then that means you have a biconditional that will also work. Okay. If one of those is false, then no. The one about eating your veggies and dessert, yeah, probably not so much. Okay. So let's talk about conditional statements. So let's practice. Okay. So if we pull out our colors, we're like, let's highlight the hypothesis in one color and let's highlight the conclusion in another. Okay. So if the hypothesis is blue, that's the if part. Okay. The input, or like the beginning, and the conclusion would be the result. Okay. And so, all right, so let's read this first one. If, okay, you take a class in TV broadcasting. So the if part, okay, again, excluding the word if. So you you take a class in TV broadcasting. So take a class in TV broadcasting. Well, then what? Well, then your result is you, again, don't use the word then, okay, you will film a sporting event. So the conclusion excludes the word then. Okay, so take a class, and as a result, you will film a sporting event. So the P then Q. So P would be the take a class, Q would be the result. You'll film a sporting event. Okay, let's try the next one. So I wear my jacket when it's cold outside. Okay, if I wear my jacket, then it's cold outside. Well, kind of, but if it's cold outside, so that's the hypothesis. So if it's cold outside, then what? Well, then I wear my jacket. Okay, so it's cold outside. As a result, I will wear my jacket. So The hypothesis, conclusion. Okay, let's look at this one. A polygon is a triangle only if it has three sides. Okay, can we do this? Well, if it has, okay, so here the if it has three sides, okay, then it is a triangle. Now look at this. If you have a triangle, then it has three sides, it goes both directions. So this actually would be a biconditional situation, wouldn't it? You know, it's a triangle if and only if it has three sides. If it has three sides, if and only if it's a triangle. So that kind of is an example of both ways are true. Okay, watch for the if as to which way they want you to put it. Okay, read the next one. We have a spider and we have a tarantula. So let's think about it. If you have a spider, then you have a tarantula? Not necessarily, hopefully not. If you have a tarantula, then you have a spider. That would be the better way. So the hypothesis would be, if you have a tarantula, then what? Then you have a spider. Okay, that's the result. Okay, so the hypothesis is the if part, excluding the word if, and the conditional or the conclusion. Okay, so it would be the result. Okay, and again, you don't include the then part. Now this says, hey, I want you to write this as if then. You're like, all right, fine. So let's write this as if then. So if I say write it as if then, I do want those words. So take this situation and write it as if then. So if, okay, I should probably not use the highlighter. So if it's raining outside, then you use an umbrella. So let's write this. All right, if it is raining outside, then use an umbrella. Okay, sorry, there may be some glitches there, but I have had it freeze up a couple times. So the hypothesis is it's raining outside. The conclusion is use an umbrella. Okay, so if I ask you to write it in if-then form, I want to see an if, and I want to see the word then. And the if is before the hypothesis, and the then is before the conclusion. Okay, so the next one is if you have adjacent angles. Okay, then what? You have a common vertex and a common side. Then, and I do want to see it, common vertex and common side. I abbreviated it for your time's sake, but that's what you would write, is that, now this is one where, like, think about it. Could you write this the opposite way? You know, you could. If you have a common vertex and a common side, well, then you have adjacent angles, okay? And so that would be an example of a biconditional, okay? So just notice sometimes it's true both ways and sometimes it's not. Okay, so the next one says, determine the truth value, okay, of this conditional or compound sentence. And so, okay, it says take two negative numbers and then add them together till you also get a negative number. I'll pick two. -2 plus -3, hey, that's -5. Huh, that's true. Anytime you add two negatives together, you're going to get a negative result. Okay, so the answer is, hey, that's true. Okay, if an angle is acute, okay, then the angle measures 35 degrees, okay? And so the question is that true? And the answer is no. Why not? Well, because if an angle is a acute angle, then the angle measures 35. Well, it might measure something else and still be acute. And so the answer is no. And the counterexample is going to be, well, you could have a 45-degree angle, okay, and still be acute. Okay, so give a counterexample and say, hey, this, if I had an acute angle, I could have it also a 45-degree angle. So counterexample says, no, I can have the same start, but not the same finish. Okay, so the next one, okay, converse, okay. Converse, like I said, is switches things up, okay, just like the shoes switched up the world, okay. And so the thing is that a compound statement is formed by exchanging the hypothesis and the conclusion. So if the original statement, the conditional was, if you have a right angle, then it measures 90 degrees. Well, then the converse of that would be, if it measures 90 degrees, then it's going to be a right angle. And so what you do then is it switches for the converse, it switches the hypothesis and the conclusion of the original. Okay, and so let's try this. Okay, so if your statement says if the measure of angle A is 95 degrees, then you have an obtuse angle. Okay, is that true? Well, yeah, it's true. Okay, and so if you have a 90-degree angle, then it's a conditional. So I don't know why I crossed it out, but it's true. And so that means that your hypothesis is so it's 95 degrees, and your result is that it is an obtuse angle. Well, then to do the converse, you say if you have an obtuse angle, then it is 95 degrees. Well, the answer to that is, are you kidding me? That's not true. If you have an obtuse angle, it might not be 95 degrees. That's false. Okay, so the counterexample is, what if it's 100? Okay, could be something other than 95 degrees. So you have to prove it wrong and say, no, it could be something different. Okay, the next one is similar. It's kind of silly. If you have a hamster, then it's a rodent. Okay, that's true. Okay, if you have then it is a rodent. Okay. Okay, well, then what's the opposite? Okay. If you have a rodent, then it is a hamster. You can't read my writing without hearing me because it's a little hard to read. But you can hear me and you can see what I'm writing. I just don't want to take a real long time to write. It's hard to write in this pen. So if you have a hamster, then the result is it is a rodent. Okay, that is fine. So I guess they're both green in this case. And then if you flip them, okay, if you have a rodent, well, then it's got to be hamster. Well, that's not true. If you have a rodent, you might have a rat. Okay, so that is false. And so the counterexample would be a mouse, okay, or a rat or something. So you write counter example, and then you give me examples. What could it be? It could be a rat, it could be a ferret, it could be something else. Okay, so converse switches the hypothesis and the conclusion. Okay, next part. Biconditional again, bi means two. So if both ways are true, well, then we have a biconditional statement we can write. Okay, so what does that mean? Both ways. Well, the conditional is the first way. So if points are on the same line, then they're collinear. So the hypothesis would be, so points are on the same line. Okay. So, and then as a result, that means they are collinear. Okay. And that's true. Okay. If you do the converse, that means you say if points are collinear, then they lie in the same line. Okay. If points are collinear, yes, that says collinear. So if points are collinear, so we got the blue part first. If points are collinear, then what? Then they lie on the same line. They lie on the same line. Okay, that's what that says. So you flip that. Is that true? Yeah. If points are collinear, of course they lie on the same line. Okay, so since both the conditional and the converse are true, so if both are true, then you can write a statement that goes both directions and use the word if and only if. And that means it's a requirement. Okay, so you go back to original, say if, okay, you don't say if, you say points lie on the same line. If and only if, so you write that 2fi, okay, 2f if, okay. So points on the same line, if and only if, okay, they what? They are collinear. Okay, so points lie in the same line if and only if they are collinear. Okay, so that's absolutely how you put a statement. Okay, that's how you put a biconditional statement. You write the original if and then without the words if and then, but if and only if in the middle. Okay, and that means it works both directions. So on the flip side, if they give you a biconditional statement where they use the if and only if, you can write it both ways. Okay, how? What do you mean, woman? Well, that means that you can write the left, then the left, then the right, and then you could do the right, then the left, and both will be true. Okay, so if you have a biconditional statement, it means the arrow goes both directions. So, and both should be true. Okay, so if I should use a pen, let's try this. If an angle is obtuse, then the angle is greater than 90 and less than 180. And let's summarize it, between 90 and 180 degrees, not including those points. So between them, okay? So it's bigger than 90, but less than 180 degrees, okay? And so then also the flip side, and that's true, okay? And the other one would be, if you have an angle between 90 and 180, then it's going to be obtuse. Okay, so I think the main things that we learned today would be, a biconditional goes, both directions. So if P, then Q, and then also Q, then P, and therefore you can say if and only if, okay, as long as both of those are true. So that's biconditional. We talked about converse, where you switch the input and output. So you switch the P and the Q and say, all right, see if it's true or false. If you ever want to show something's false, you use a counterexample. And then a conditional is if and then. And if I want to talk about, hey, what's the hypothesis? You leave off the word if. You say it's raining outside. And then the result or conclusion would be use an umbrella. Okay. So those are the main things we talked about today. Best wishes. Come see me if you need me.